Welcome to The Explainer. Today, we're digging into something huge, the hidden energy bill behind AI. We're going to talk about how everything from a simple question you ask your phone is adding up to a global power demand that's, believe it or not, on the scale of entire countries. So, where do we even begin with this? Well, let's forget the huge global stats for a second and start with something you probably do every day. You ask a question, right? And boom, you get an answer. It feels seamless. But behind that simple little exchange, there's this hidden energy cost that's, well, it's starting to add up in a really big way.
Okay, so check this out. Just one single question you throw at a chatbot like ChatGPT can slurp up to 10 times more electricity than a regular old Google search. Now, that might not sound like a lot for just one query, but you have to remember, multiply that by billions of users, and suddenly that tiny difference becomes the starting point for a massive global story.
All right, let's zoom out. We're going from that one click, that one question, to the absolutely colossal scale of AI's energy appetite. We're going to see how it's already shaking up global power demands. So, get ready for this number, 415 terawatt hours. That's what data centers are on track to use just in 2024. Now, a terawatt hour it's a huge amount of energy. I mean, just one of them could power something like 60,000 American homes for a whole year. So what does a number this big actually mean for the whole planet? Well, that 415 terawatt hours, it works out to about 1.5% of all the electricity used on Earth. I know, 1.5% might not sound like a jaw-dropping number. But here's the kicker. It's the speed at which that number is climbing that has everyone's attention. And it's pretty much all being driven by the AI boom. And to put that into an even crazier perspective, just look at the US. The data centers there, on their own, use more power than the entire country of Pakistan. We're talking about the infrastructure for AI in just one country needing more juice than a nation with over 230 million people. That's wild. And this trend, it's not slowing down, it's actually speeding up. By 2030, the forecast is that global demand will more than double, rocketing up to almost 945 terawatt hours. And to give you an idea of what that looks like, that's basically what Japan, the entire country, uses in a year right now. So here's the big takeaway. When we talk about the power needed for our AI future, we're not talking about a few extra power plants anymore. We are literally talking on the scale of entire industrialized nations. Okay, so where is all this electricity actually going? To really get it, we need to pop the hood on AI and see that it's not just one thing. It's really two very different power-hungry processes.
First up, you've got what's called model training. You've probably heard about this part. It gets all the headlines. Think of it like sending an AI to college for a really intense degree. It's this super power-hungry, but generally one-time, process of feeding it mountains of data. And yeah, it can use a staggering amount of energy.
But then there's inference. If training is college, inference is the AI's entire working career. This is the energy it costs to actually use the AI, day in and day out. It's every single question you ask, every image it creates, every line of code it spits out.
And this is where a really common misunderstanding comes in. Yeah, training is a beast energy-wise, but it's a sprint. Inference? That's the marathon. The cumulative effect of billions of us using these tools every day, that's the real energy giant here. We're talking as much as 90% of AI's total power bill. It's just staggering.
So this incredible demand, it's not just some abstract number on a spreadsheet. No way. It's creating very real, very tangible problems for our power grids and our infrastructure right now. Take a look at places where a ton of these data centers are clustered together. The strain is becoming, well, critical. In Virginia, for example, a state that handles a huge chunk of the world's internet traffic, data centers are now eating up more than a quarter of the entire state's electricity. That puts an insane amount of pressure on a power grid that, frankly, was never built for that kind of focused demand. And listen, that strain isn't just some headache for the power companies. It can actually hit you and me right in the wallet. In some places, the cost of beefing up the grid to handle all these new data centers gets passed right on to the residents. So yeah, it can literally make your monthly power bill go up. So the big question is, where is all this electricity coming from? Well, here's the tough part. The majority of it, over half, is still coming from fossil fuels. And that creates this fundamental conflict, right? You've got this amazing AI boom on one side and our global climate goals on the other.
This dependence on fossil fuels has kicked off this huge race to find clean energy solutions. The industry gets it. They know you just can't scale the AI revolution for the long haul on carbon-based energy. It just doesn't work. So what are they doing? Well, the big tech companies are making these really ambitious climate promises, and they're pouring tons of money into dedicated wind and solar farms. But here's a twist I bet you didn't see coming. They're also a major force behind the comeback of nuclear power. Why? Because nuclear provides that stable, 24/7, zero-emission power that a hungry AI data center needs to run all the time.
And this isn't just some idea they're kicking around. It's actually happening. Nuclear plants that were shut down, like 3 Mile Island, are literally being brought back to life specifically to feed AI's relentless appetite for power. And looking ahead, everyone's talking about these next-gen small modular reactors, or SMRs, coming online. Which brings us to the most important takeaway here. For businesses, and really for all of us, AI isn't just a tech problem anymore. It's not just about servers and code. It's now fundamentally an infrastructure problem, a cost problem, and an energy problem. So if you're a business leader, you're suddenly facing this really critical set of decisions. It's a super complex balancing act, right? You've got to manage these skyrocketing energy costs. You've got to meet your climate goals. And you've got to worry about the risk to your reputation if your AI isn't seen as being green. So, at the end of the day, the challenge is pretty clear. How do we get all the incredible benefits of this AI revolution without letting its massive energy and environmental footprint get totally out of control? And that leaves us with one final and I think really crucial question to think about. We all know AI is going to get exponentially more powerful. The question is, can we innovate on the energy side fast enough to keep up? Can we make things more efficient? Can we build out clean power sources fast enough to match that growth? Honestly, the answer to that question is going to define the next decade.
All right, let's jump into the world of AI and figure out what it's all about. This used to be just science fiction, right? But today's AI is getting there, and that raises some big questions.
So, to see where we're headed, we gotta know where we stand. What exactly is AI today? Basically, AI is all about teaching machines to think and learn, kind of like we do.
And you're already using it every single day, probably without even realizing it. Okay, so today we're at narrow AI. It's great at one thing. The future, that's AGI and ASI.
The next big step for AI? It's not just about thinking. It's about seeing and hearing the world.
And that's called Multimodal AI. It pulls together different info, like text and images, for a fuller picture.
So how's it work? It encodes, fuses the data together, and then generates one smart combined output.
And this is already out there, solving real-world problems in medicine, manufacturing, you name it.
But all this amazing power, well, it comes with a price tag, a big one.
Just look at the energy consumption. The amount of power AI needs is just massive, and it's growing fast. And here's the kicker. A huge chunk of that energy, it's still coming from fossil fuels.
And inside the system, there's a major flaw. AI can hallucinate. Basically, it can make stuff up. Plus, it's pretty brittle. It struggles with new things, showing it just doesn't have our flexibility.
So all this leads to one of the biggest challenges in the entire field of computer science.
The more powerful these things get, the more we need to be sure they're on our side, you know?
So researchers are trying a bunch of different ways to tackle this, from all sorts of angles.
Okay, so with all this going on, how are we trying to govern this incredibly powerful tech?
Well, governments are finally stepping in. A great example is the European Union's new AI Act.
A big part of it is transparency, making sure you know when you're dealing with AI-generated stuff.
And this really gets to the heart of it. Who gets to decide our future with AI? It has to be us. We're building something that could be smarter than us. The real question is, are we being smart about it?